What's up guys, it's me Yajit, and in today's video I'll be talking about a recent project which I made, which is face detection using artificial intelligence. Wait, what is even artificial intelligence? Artificial intelligence may seem like a complex topic, but it actually isn't. Artificial intelligence is simply the computer science of making intelligent machines. And artificial intelligence itself has many different fields. And an example of such a field is machine learning. Remember, I talked about that? Yajit, what are you saying? We never talked about that. Oh, yeah, sorry guys. Let me just get right into that. As I said, machine learning is a field of artificial intelligence which allows a computer to learn without being explicitly programmed. Okay, now that we are done with all those definitions, I can finally get on to what my project is exactly about. So, if you don't know already, my project was about face detection. And to code this project, I used a machine learning library as OpenCV. Though, why OpenCV? Well, the simple reason to why I used OpenCV was because it's a great library for live video feed, and that is something which I was using in my project since, as you know, I use my laptop's webcam to actually detect me, which was using this, and also it's great for images, which was also a big part of my project. Just as a note, before continuing this video, I want to tell you all that this video will not exactly be about the code, but instead about something known as hard cascade, which I'll be just introducing in a second. And that's because I think the video will be too long if I include the code and all, though I'll be actually making a YouTube video about it next week, so don't worry about that, and you will be able to see it soon. I know I just said that I'll not be including the code, but I'll actually be just telling you a little bit about it because it's really important to understand what exactly hard cascades are. And so let me just explain you the code for a bit. So as I said before, I'll be just explaining the first two lines of this code. Basically, the first line is just import CV2, which is importing our library OpenCV here. And the second line over here is the most important, so pay more attention to it. And basically what this is, it's loading our classifier, or you can say machine learning model. Basically, if you don't know, a classifier is basically something which assigns a strict label to an image and tells the computer about it. So an example of a classifier would be a dog and cat classifier. What this would do is basically it will tell the computer the difference between a dog and a cat, and it would put a label to it. And so basically, if the image was a dog, then it will tell the computer it's a dog. But if it was a cat, it will tell the computer it's a cat. And that's what I'm doing here. But this is not a dog and cat classifier, but something different. And it's a classifier for faces and tells the computer what is a face and what is not. And this is really important because computers just like a human in a way. It learns after actually understanding something. So if the computer is not even introduced to a face and not even told what it is, then how will it even detect what a face is? And how will it put a rectangle or a bounding box around the face? That's why this line over here is really important. And this line is also, as you can see, has a word known as hard cascade. And this is something which is really important, which now I'll begin discussing. So let's begin with talking about hard cascade. So if you don't know, hard cascade is an object detection algorithm just used to train something known as a cascade classifier. This cascade classifier requires a whole process to train. But not only that, it also requires a set of positive and negative images. Basically, these positive images are images of the object or thing we want the classifier to detect. And in our case, it would be images of faces. And the negative images here would be random images, which are images of non-faces. And these images could include anything like a pillow, a ball, a phone, or anything like that. And this lets the computer know that this item or thing here is a face, and the other thing is something which is not a face. So this is something which is also really important to the training of the cascade classifier, but the process is even more important, and it's actually really interesting on how it works. So let's get into that now. So the first step involves something known as hard features. You'll need to know about these features because they're really important as a part of the first step. And basically, so these hard features are basically adjacent rectangles with the color white and black, which scan around the image to detect edges and facial features of the face. And basically, if these features notice that at in the white part there is lighter, and in the black part is darker, or it may be also be the opposite, it can detect it's an edge, because as you can see when you're looking at my face, obviously this part is more darker than the part which is over here, and this helps the computer understand how to actually detect an edge. And if you want to go in the mathematics to this, basically what it does is that the pixels at the white part, it sums all of them up, and then the pixel at the black part, meaning the black side of the hard feature, it sums them and it finds the difference between them. And the difference, if it's closer to 1, then it basically tells you the edge that an edge is detected, but if it's not, that means the edge is not detected. And these hard features go all around the image. So if a hard feature was right here, it would move here and keep on moving and help detect my face. And hopefully you understand this step now, because I'll now be moving on to explaining the second step. So the second step is quite related to the first step, and you'll understand as I'll talk about it. So basically this step requires you to create something known as integral images. And basically what these integral images do is that, remember I told you that you have to add all the pixels on each side of the hard features. So the white, you add the pixels at the white side and the black too. So basically this process may not seem to take too much time, but it actually does. And creating these integral images basically make this process a lot more easier and efficient, and so it allows the computer to detect a face and edges a lot more easier. So that's basically all in creating integral images is really about, and you don't really need to understand anything else right now. But now I'll be beginning to talk about a technique known as AdaBoost, which is step 3. Okay, so now we are on step 3. So as I told you, step 3 is about implementing a technique known as AdaBoost. If you didn't know, there are actually many of these hard features. There are more than 160,000 of them, and that's a lot. And many of these features are not even useful to actually be detecting edges and a face. And that's why, instead, to make this process a lot more simpler and to use hard features which are actually good to detect the face, we use this technique known as AdaBoost, which basically implements all those hard features one by one to create V classifiers. And these V classifiers, basically the ones which produce the least error, are chosen to actually be implemented when actually detecting an edge and face. And usually there are about 6,000 of them selected to actually be used, and these V classifiers create a strong classifier. And that is step 3, AdaBoost. And now finally I'll be moving on to the final step, which is step 4. Now we are on the final step, which is known as something called stages. Basically, say that we are implementing a hard feature at this side of an image. So basically this is my face right now. Images, say this is a computer and it's putting a hard feature right here, because as I said, it goes over the whole image. And if it begins with here and implements all those 6,000 hard features right here, and the size is becoming bigger and all of those things are happening, then that will take a lot of time. And if this is not my face, then that's a huge waste of time. And to make this process a lot simpler and more efficient, something known as stage is implemented. So I think all of you know what a stage is, but not the actual stage, but like basically, all those hard features, we split them up. So we create many stages, about 35. It depends on how many hard features are chosen, how many V classifiers there are. So those hard features are put into those stages. So stage 1 has a few hard features, then stage 2 has a few hard features, and so on. But how is this making the process more efficient? So to make the process more efficient, basically the stage 1 contains simpler hard features and so on. But to make the process more efficient, what it does is that, say that it's implementing the features of stage 1, and if those features don't detect anything and are thinking that there's really nothing there, then it actually moves on and skips the window. And if you don't know what a window is, basically it's like a portion of the image, and basically it skips that portion of the image or window if it doesn't detect anything on the stage. But if it does detect something like an edge, then it uses its next feature, hard feature specifically, and keeps on doing that. But if the stage fails, it just moves on, but if it doesn't, it moves on to the next stage, and so on. The process is repeated to make the whole thing a lot more efficient. So well, that is all about the process. Well, that is the video. I really hope you enjoyed it and found all this about hard cascade classifiers really interesting. By the way, just as a reminder again, remember, I'll be creating a tutorial on how to actually code my thing and how to actually code this phase detector. Other than that, see you next time. Bye. Wait. I was just joking. The video is actually not over until I actually tell you something really important. If you liked the video, smash that like button and don't forget to subscribe and click that bell so that you can know when my future videos are coming out. Other than that, see you next time. Peace out.